So, like, what we were doing here was we were focusing on translating from a scenario that is written out in English, and we were working on translating that into the algebra language. And some of the key things we were looking for to help us with that translation, which is, for example, right here, like, you put y equals, excuse me, 5 plus 2x in your translation, and that's correct. So in each one of these algebra statements, there's going to be a y variable and an x variable. Basically, they're abbreviations for things that can change, but they're also connected to each other. They're in a relationship with each other. So when one changes, the other one's going to change as well. And like in this question, let's see here. The letter Y, oh, it even tells us the letter Y is the ladles of broth for this recipe or whatever. And X is the minutes since he's added the seasoning. Very specific. But as one thing changes, as the minutes go on, as time goes on, he's probably going to be adding more and more ladles of soup or something. I don't know, but let's read through it. And I'm just going to see what's going on with this one. It says Liam knows the key to making creamy risotto, a rice dish, is to add the liquid to the rice gradually. He adds 5 ladles of chicken broth to his rice before adding seasoning, and then he continues to add 2 ladles of broth each minute. So there's our rate word, each. Some other rate words we've encountered are like the word per, for every, just to name a couple. So the two numbers, the way I've described them in our lessons is that we have a starting number, which is right here. He adds 5 ladles of broth right away. So in the pot or whatever, he starts off with 5 ladles. So since y is ladles of broth, the way we would translate that into algebra would be the number of ladles of broth, y, equals 5, which is what he starts with. And then it says he adds 2 ladles each minute. So 2 is like the rate number. And so we would say, and then if you think about it, we're adding to what's already there. We're not taking it away. So we're adding ladles of broth to the 5 ladles that are already in the pot. So we're going to be adding plus 2 ladles per minute. And we always take that rate number, and this one is 2, and multiply it by whatever x is abbreviating. We just basically put x there. And so just as a, just to test one out, if we had, if let's say like 6 minutes have passed, because x is minutes, how many ladles will be in there? Well, it's going to be 5 plus 2 per every minute. So we would multiply 2 times 6 minutes, which would be 12. So he's added 12 to the 5 that was already there. 5 plus 12 is 17. So like that's how we can use the translation to get these answers. A ski resort rents snowshoes in the winter. The resort charges $7 per day and a flat fee of $3 to cover cleaning. So there's the rate word per. So that means that 7 is my rate number. 3 is my starting point number. So the total cost, y, equals $3 plus 7 per day. And you can see that's what you got right here. And even though it says the correct answer, they like rearrange them the other way around. You'll notice here that they have like a check mark. You got it right. So having them rearranged the way or arranged the way that you've written them, I personally would prefer, like, to me and the way my brain works, it makes more sense in the translation to start off with the starting amount, like $3, and then indicate whether the rate is adding on to that amount or subtracting from it. And I don't know, it just makes more sense to me, um, to do it like you've done it here. But just be mindful that on the GED test, you might arrange it like you and I are doing here, where we put the starting number first. But it's possible, if not likely, that if you get this as an answer, y equals 3 plus 7x as your translation, that you look at your multiple choices, A, B, C, and D, and you don't see anything that looks exactly like that as a choice to choose from. But just take another look, because probably what happened was they took your numbers that you put and they rearranged them in the opposite way, or in the other order, because they like to do that. For some reason, they like to put the rate number first and then add on the starting number at the end. One final thing before I move on from this skill is that I want to talk about the official names for these numbers that I've been referring to. So the starting number is what goes in that first box, or that's what we've been doing anyway. We put the starting number first. That is officially called the y-intercept number. Y-intercept. So if you ever go on YouTube and watch videos, instructional videos there, or looking at a textbook or something, they're going to use that word, y-intercept, to mean what you and I've phrased or described the starting number. They just use y-intercept, and I don't like that phrase. It's very technical, but it is good to know what it means if they say it. Also, the number that's multiplied to x, the rate, sometimes also called the rate of change. In textbooks, online, the traditional name for that number is slope, which is, again, another word that I really don't like because it's not very descriptive. Like, slope is a word that I think of when I'm going to go sledding or something, not really like the cost of gas per gallon. I don't think, oh, I'm paying a slope of $4.99 per gallon, like that. What, that doesn't make any sense to me. So instead of using the word slope, we've been using the word rate. So I wanted to make you, or just reiterate that. We may have talked about that before, but sometimes this structure of translation is referred to as the slope dash y-intercept. Slope-intercept form of a linear equation. It's a slope-intercept. I don't know why I put y. They usually just say slope-intercept form of an equation, of a translation. And that's where they get those names, slope and intercept. Boom, boom. Okay, so we've got this scenario. You got $30 in an envelope. Lunch costs $2 per day, and you use the money in the envelope to pay for lunch. That's all. And then it says, write a linear equation to show the relationship between the days that have passed and the money remaining. When you read that, and like you haven't practiced algebra a whole lot, you're like, what in the world are they asking me to do? So what happens is a human nature kind of thing, where if we don't know exactly what they're asking us to do, we come up with a question ourselves and then answer our own question. A lot of people would look at this question and think, okay, I got $30 in my envelope, lunch costs $2 per day, use the money in envelope to pay for lunch, right? So they would read all the instructions, and then a lot of people a lot of students first starting out in algebra might think, okay, I got to figure out how many days I can buy lunch with that $30. How long, like, how long will it take for that $30 to go down to zero, maybe? Or a question like that. So the tendency is to want to solve something. That's what we think of when we think of math, is that we're trying to solve something and get an answer. Like in this case, it would take 15 days. If lunch costs $2 per day, 2 times 15 is 30. So it would take 15 days to spend all of that $30 in the envelope. But that's not the question that's being asked here. What they want us to do is they want us to translate into algebra. That's what they want us to do. They want us to take this scenario that I have written out in English and translate it into the algebra language. Write a linear equation, blah, blah, blah. They want us to translate this scenario into algebra language. So if we purchased 1 day of lunch, or like we took out enough money for 1 day of lunch, how did we get 28 as an answer for how much money remains? So we're trying to figure out, what did we do? What did I do to get 28 as an answer? Well, I started with 30 because that's how much money it started off with in the envelope. And then I took away $2, and that's equal to 28. So there you go. The next one, how did I get 20? If 5 days have passed, how do I know that $20 is left in the envelope for lunch money? So how did we get 20? Well, we start with $30 again. But then I was saying, okay, well, if it's 5 days, basically 2 plus 2 plus 2 plus 2 plus 2, 5 times, that would be 10, spending $10 on lunch. So $30 started off with, we took away 10, there's only $20 left in the envelope now. And then for the final one, we could say 30 minus one additional day, so $12 equals 18. Next thing I'm going to do is I'm going to tweak this a little bit. I'm going to change it a little bit. So like instead of saying 30 minus 10 equals 20, let's focus on the 10 part. 10 stood for how much money this person was using for lunch. We got 10 because it was like after 5 days. Okay, 5 days of lunch cost $10. $20 remains in the envelope. So we got 10 here by doing 2 plus 2 plus 2 plus 2 plus 2 5 times. That's the same thing as saying 2 times 5. Okay, so instead of writing 10 there, I'm putting 2 times 5. So as you look at these 4 equations, there are some things that change and some things that stay the same. 30 shows up in every single one of these equations. That number stays the same, 30. The part where it says minus 2 times something. By the way, this parentheses, when you put a number and then a parentheses right after it like that, that means multiplication. Okay, that's a way to show multiplication in the algebra language. But if we look specifically at just where it says minus 2 times something, so let's put that down. So minus 2. And then all of them also have an equal sign. The other numbers are numbers that change. So this 0, 1, 5, 6, those change, from equation to equation, from one to the next. But they all do have something in common. They all represent the number of days that have passed. In other words, how many lunches you've purchased. Instead of putting those specific numbers, I'm going to write the word days, meaning whatever number goes there represents the number of days that have passed. In a similar way, I'm going to put money on this other side, money remaining. goal is to get this to look just like pure algebra language. Because right now there's a mixture. I put those extra words in there, like days and the money that remains. Um, we want to get this into pure algebra language. So to do that, instead of using the word days, I'm just going to abbreviate. I'm going to abbreviate the word days with the first letter of it, D, and I'm going to rewrite it with that new abbreviation. 30 minus 2 times D equals, and then the same thing, I'll just put a money sign over on the right side for to abbreviate money that remains. All right, so all we've done so far is just we've abbreviated these words into something that's easier to write, just a single letter. At this point, right here, where it says 2xd, or 2 with the traditional multiplication symbol, in the algebra language, this would be considered bad grammar. So, like, you know how in English, how if, I am a math teacher, if I put that and I didn't do anything else to it, you understand kind of what I'm saying, but it's bad grammar. Like, in other words, it should be fixed. We should take that and make it into a capital I, and then we should also put a period at the end of it. That's what I mean by grammar. Bad. So by doing that, I fixed the English grammar. I fixed it. In the same way, this little extra little x right here is bad grammar for algebra. So to fix it, all we do is take it away. We just erase it. We've only actually got one more step to go to get this into pure algebra language. And it's this step. We're going to change these abbreviated letters like D. We're going to change that abbreviation to the letter X. And we're going to change the money sign abbreviation, the money that remains in the envelope, to the letter Y. And then we're going to keep everything else the same. And now we have a sentence in algebra that is pure algebra language. 30 minus 2x equals y. In the algebra language, x and y's are like the standard way to abbreviate things that can change. So on one question, on the GED test, let's say on one question, the letter X might be an abbreviation for days that have passed. On another question, the letter X might mean an abbreviation for the number of gallons that you pump into your car at the gas pump. On another equation, X might mean like the number of hours that you've driven, at 65 miles an hour or something. All right. And when we're doing this, we're being asked to write a linear equation, or otherwise known as a linear function. For now, just know that you can basically substitute the word function for equation, and you're going to be in okay shape. So if you see that word function, just think equation. The more important word, in my opinion, is the word linear. So if it says linear, when you see that word, always think it's going to have an X and a Y in it. X and a Y. In these questions, it does provide the meaning of the letter Y and the meaning of the letter X. So like it tells us what Y is abbreviating. In this question, Y is abbreviating the elevation of the feather, whatever that means, and the letter X is abbreviating the number of seconds it has been falling. So a lot of times they will explain what a letter like that is abbreviating in a very similar way. Okay, it's going to usually on the GED test it would tell you the meaning of the letter Y and the meaning of the letter X, because Y and X is always used, right? But they change meaning every single question. But if it doesn't tell you that, because sometimes it doesn't tell you that, there are a couple ways that you can figure out what the Y value is and what the X value is. One way is something I think I've already mentioned in the previous video. If you go to your rate number, which in this case it says 2 per second, the thing that comes first, like the label specifically, is the meaning of the letter Y, and the thing that comes after the word after the rate word is the meaning of the letter X. So Y is representing feet, X is representing seconds, and you can see that that matches up down here. It's always going to be like that. That's one way to do it. Sometimes, though, the rate, the way that they describe, or just the wording that they use in English, it's not quite as clear cut as like 2 feet per second. It might give you something like it. Each second, the feather drifted to the ground 2 feet. Like it might change it up, so it might be a little bit confusing as to which one's the X and which one's the Y if it's not written in this nice blank per blank way. But there is another way that a student helped me discover, actually, just a couple, like recently, like this past week. If you can pick out your starting number and you look at the label of that number or whatever that number means, that's what the meaning of the letter Y is. Always the letter Y. Always Y. So here we're going to get right into it. It says a chicken is born weighing 1 ounce. It gains 2 ounces each week. Write an equation that shows the relationship between the chicken's age in weeks, comma, X, and its weight in ounces, comma, Y. So Y represents this chicken's total weight, and X represents a changeable value or a changeable number, which is representative of how old the chicken is in weeks. So here's our Y. It says Y equals. So basically, you would interpret that as the total weight of this chicken is 1 ounce plus 2 ounces, an additional 2 ounces every week. So as every week goes by, we would time whatever week it is. After 1 week, X, the changeable letter X would be 1. After 2 weeks, the changeable letter X would be 2. But however many weeks are going on, you would multiply that week number times 2, because it goes 2 ounces each week, and then add the starting weight of the chicken. And that's what we're doing in this type of question. We're not solving anything. It's not asking us like, how heavy is the chicken after 10 weeks? It's just asking us rather to more like translate it. Translate it from an English, or translate it from the scenario that's presented in English, translate it from the English to the algebra language, which uses these changeable letters Y and X. This one says Kinsley is refinishing her wooden deck. She completed 10 square yards over the weekend, and during the week she will refinish 8 square yards per day. Write an equation that shows how the total number of square yards, comma, Y, depends on the number of weekdays she works, comma, X. So here, the letter Y represents something different than what it did in the previous question. The previous question, it was the total weight of the chicken. In this scenario, the letter Y is the total area, basically, of the deck, how big the deck is. Same idea for X. On the last one, X was weeks that have passed. On this one, it's actually days that have passed, weekdays. Anyway. The total size of the deck, Y, equals, well, she has already completed 10 square yards, and she's going to add to that 8 square yards per day. So Y equals 10 plus 8x. Hassan knows how to sing 6 vocal pieces, thanks to his choir class. Now he's about to start private lessons. His teacher says he will learn two new pieces each month. Write an equation that shows the relationship between the number of months he's taken voice lessons, comma, X, and the total number of songs or total number of pieces he knows, comma, Y. So the songs that he knows is calculated by or is equals the 6 that he already knows plus he's learning 2 each month. So 2 times X, 2 each month. Now, if I hit submit here, it's going to take that answer. It's going to be totally fine. But after, I mean, this is the third one we've done. You might start noticing some patterns. Okay, I'm going to hit submit, and we'll dive a little bit more in detail about what those patterns are. But be on the lookout, like as you are either whether you're rewatching this video or kind of leading into the next question, you might have already started noticing some patterns of how I build the equation. But let's go on. Reed just got a pet feeder for his cats and filled it up with 8 cups of food. The feeder will dispense 1 cup of food each day. Write an equation that shows how the number of cups remaining, comma, y, depends on the number of days the pet feeder has been used, comma, x. So y is the total amount of food that's remaining, and x is how many days the feeder's been in use. All right, so the total amount of food in this feeder starts at what? 8. It's filled up to the top with 8 cups. So it starts at 8. The feeder will then dispense 1 cup of food each day. So when I think of like the word dispense, I think of like a dispenser or something that you're getting rid of something, you're dispensing of it, you're disposing of it, like it's going away. So the feeder will get rid of 1 cup of food each day, and that makes sense in real life, right? I mean, like you fill up the thing, and then every single day, as the animals go to the pet feeder, it's letting loose food for them. So it's this pet feeder starts at 8 cups of food, and then it loses or dispenses 1 cup of food each day. So the total number of cups remaining, y, is calculated by starting at 8 and subtracting 1 for each day. All right. So let's talk about some of the patterns here in this question, because if I hit submit, it's going to say that's okay. But let's talk about patterns. But there's a starting amount right here. In this case, it was 8. Then we are like either adding or subtracting. In this case, it was subtracting because it was going, the food amount was going down. But we're either adding or subtracting an amount. And the amount that we're adding or subtracting is based on a rate. And we take that rate number and we times it by the other changeable number x. And that's the general structure of our equations. We have a total, which is y, equals, it starts at something, which is this red box, and then we either add or subtract another amount as x changes. And that amount that we're adding or subtracting is a rate. So in this case, the rate was 1 cup of food each day. It was dispensing it, so it was being taken away, hence the negative. But 1 cup of food each day. When you're identifying your rate words or your rate numbers, look for words that can help you as a clue, like the words each or like per or something like that. 1 cup of food each day, so 1 is a rate number. And there we go. Okay, this looks like a good one. This is what I want to get to. So clear screen. Okay. Samuel is boiling water to cook pasta for dinner. The water in the pot starts at 67 degrees Fahrenheit, and the temperature increases by 13 degrees Fahrenheit per minute. How long does it take for the water to reach 145 degrees Fahrenheit? Then the instructions said, write and solve an equation to find the answer. Blank minutes. All right, so let's look at our three numbers. It says the water in the pot starts at 67 degrees. So 67 degrees is our starting point, our starting number. The second number, it increases by 13 degrees per minute. The word per is a rate word. It increases that much per minute, so that's a rate. It's a rate number. 13 is a rate number. Now, in the previous questions we've done on this video, that's pretty much all the information they gave us. They just gave us two numbers. One of them was a starting number, one of them was a rate number, and we were going to build our equation based off of those two numbers. And that's what all they were asking us to do. So if we were to continue to do that exercise, the equation would look like this. Y equals our starting number, 67. It increases, so plus 13 per minute, 13 times x. And that would be our equation. Y equals 67 plus 13 times x. Okie doke. Now, notice in this question, in the instructions, nowhere in the instructions do they mention the letter y or the letter x. However, there are two things that are changing in this question. So as time changes, the water increases in temperature. So there's two changeable values, meaning two variables. And the letters y and x are are just the generic letters that algebra language uses. So I haven't talked about this explicitly yet, but I kind of hinted at it earlier in the video. Even though the letters y and x change meaning based on whatever the story problem is, the letter y is always some sort of total amount or total, whether that's like total money, total weight, in this case, total temperature. The x value is most often a time measurement. In this one, it's the amount of minutes that have passed. Another way that you can, so that's one way that you can wrap your head around like the meaning of the letter y and the meaning of the letter x, even if they don't tell you in the question. Like in this one, they don't describe the letters y and x for us, but we've identified that the temperature changes based on how long this water's been heating up. So those are two variables. So we use letter y to represent a total, in this case the total temperature, and the letter x meaning like how much time passes by. Sometimes the letters y and x are referred to as the control variables and the dependent variables. So if this was a real life scenario, think about what you can control by your direct actions, and whatever you're controlling is often also that's the x variable. So if this was us doing, or if this was you doing this, you control, you know, putting the pot on the stove and taking the pot off. So you're controlling how long the pot is on the stove, and so that's your x. As a result of that, the temperature rises, and that's your letter y. Now, here's even a better. So I just discussed two ways to determine the meanings of x and y. Now, the third way is my favorite because there's really no mystery to it. I mean, those first two things are good to know, but here's the best way, in my opinion. Look at your rate. 13 is our rate in this question. 13 degrees Fahrenheit, and then the rate word is this word per. So 13 degrees Fahrenheit per minute. Since we know that 13 is the rate, we're gonna go to that word per, the rate word, And whatever comes directly before the word per, to the left of the word per, is represents the changeable letter y. So 13 degrees Fahrenheit. So the degrees Fahrenheit part represents the letter y, the temperature. Whatever comes to the right of the word per represents the changeable letter x. So to the right of the word per is the word minute. So that means that x represents minutes that have passed. And you can always depend on that. Whatever comes to the left of the word per is your y, and whatever comes to the right of the word per is your x. All right. So that was a lot of stuff right there. That was a lot of like I just, I felt like that was a good opportunity to discuss those things. And as far as like how long it would take to answer this question, I just went off on a little bit of a tangent there. And you might have looked at this question in this video and been like, I got the answer to that like 5 minutes ago. So I did go off on a little bit of a tangent there, but I think those are some handy things to know and useful things to know. All right, now let's dive back in to this question and look at where we are. We've pulled out the starting number, we've pulled out the rate, we've built the equation. We can do that pretty quickly. Once you know what you're looking for, you can do that in a matter of 20, 30 seconds. All right, so let's pretend that we've only spent about 20 or 30 seconds so far on this question, because I think that's the level of speed you're going to be able to get when you practice this enough. We got our starting number, our rate number, we built our equation. Now there's a third number in this question. It says, how long does it take for the water to reach 145 degrees Fahrenheit? That's our third number. So the third number, 145, here's what we got to ask ourselves. Is this 145 a y number, or is it an x number? We can know that based off of some of the strategies I've already discussed. Look at your word per. To the left of the word per is temperature, and whatever comes to the left of the word per is the y, the meaning of the letter y, the y numbers. So temperature is a y number. It says, how long does it take for the water to reach 145 degrees Fahrenheit? Well, guess what? That's a temperature. So 145 is a y number. Why is that important? Well, we can go back to our equation and we can change the letter y in the equation to the y number that they're providing for us. So y changes to 145. Now we have a dependable method that we don't have to rely on like guess and check or any other method, even though that could work for you and that's totally fine. But this is a kind of a methodical way of approaching this that's going to work for you every time. Just kind of grinding out the answer. You can follow these steps. All right, so we've determined 145 is a y number. We changed the letter y to the number 145. And now what we got to do to finish the answer is to figure out what letter for x makes this thing true. What does x need to be so that this equation is true? Another way of saying that is we need to solve this equation for x. This 67 is a positive number where it stands. It's not being subtracted. It's basically like a positive number. It'd be like it was adding. So rather than use the word get rid of it, I actually think a better word is we're going to move it. We're going to move it from the right side of the equal sign to the left side of the equal sign. And when you move a number from one side of the equal sign to the other side of the equal sign, it switches. So if it's a positive number on the right side, it switches to a negative number on the other side when we move it. Another way of saying that is if it's a plus number on one side, we move it over to the other side, it's now a subtraction number. So 67 is going to become a subtraction number. And so it's going to look like this. Basically, 145 minus 67 equals 13x. And 145 minus 67 78. Now the 13 that's in front of the x is the other number we need to move over. The 13 is being multiplied by x. So 13 is a multiplication number on the right side of the equal sign. So when we move it, it's going to become a division number when we move it over to the other side. So it's going to look like this. And so it says 78 divided by 13 is equal to the letter x, the changeable letter x. So we just do 78 divided by 13. And our answer for x is 6. So 6 6 is the value of x. 6 is the only number that x can be so that this original equation is true. Like if x right here, if we change that letter x to the number 6 and we did 13 times 6, that should give us 78. We add 67 to that, we're going to end up with 145. So 6 is the number for x that will make this equation true. Therefore, it's the solution. 6 equals x. And remember, x stands for minutes. So 6 minutes is our answer. All right. All right. So he finds that a car can be rented for $229 per night. That's a rate. So I already know that that Y, it stands for money or total cost. And that nights, the number of nights he's renting this home is the meaning of the letter X. See, I already know that based on this word per. In addition, there's a one-time cleaning fee of $89. What is the cost of a 3-night stay? All right, so you could probably do that in your head, or like fairly quickly, intuitively. The cost of this stay, Y, equals basically $89 plus $229 per night per X. 3, it says, what is the cost of a 3-night stay? So 3 is an X number. So we're going to change the letter X to 3, and we're going to solve the rest of this. So basically 89 plus 229 times 3. We're going to follow order of operations, meaning doing multiplication first. 229 times 3 plus 89 gives us the answer of 776. Our total cost, Y, is equal to $776 when we stay for 3 nights. You can always challenge yourself in math, by the way, basically by seeing how fast you can answer a question while still remaining accurate. So a little bit more on that. The GED test is a balance of accuracy and speed. That's not unique to the math test. That's for every test, but it's a balance of accuracy, meaning the correct answer, and speed, how fast can you do it. And so, if you feel like you got the accuracy part down, like, you're feeling good and confident about a skill, you can always challenge yourself by seeing how fast you can do it, speed, and still remain accurate.